Well, howdy guys, we're here to do the Penny Stoichiometry Lab. Now, back before 1982, all pennies used to be made out of copper. A lot of countries did this. Copper is non-reactive, doesn't like to really react with a lot of things, and it was really cheap. So that's what they made really cheap coins out of. And it was pretty effective. However, supply and demand issues, their copper started to get more and more and more expensive. So the cost of producing a penny was getting greater than the actual value of the penny, right? It cost more money to make a penny than it was worth. So it didn't make a lot of sense. So to be more cost effective, they started making pennies out of zinc as a core on the inside, because zinc is cheaper, and then still plating the outside with copper, because copper is still not very reactive. Well, we're going to expose that and take advantage of that. So this lab is going to have us cutting down the edge or a notch in there and exposing the zinc in a penny, and then we're going to put some hydrochloric acid on it, and it is going to react with the zinc on the inside. We'll leave it over a day, and then we should be left with the copper shell. All right, and so we'll get to see that in just a second. But first, the safety precautions for this is make sure you wear your safety goggles at all times, because we are working with some pretty concentrated acid, and it can cause some issues. But other than that, don't drink it, don't get it in your eyes, and make sure that it's all flushed down the drain. HCl can be neutralized and put down the drain easily enough. Okay, well, we will file down the penny. We will put some acid in it, we'll let it sit for overnight, and then we're going to dry off the penny, and then we'll weigh the penny afterwards, and that will be just the mass of the copper at the end.
Okay. Yes, page 5 minutes, sorry. Oxygen, but I also know those two, which are some of our diatomic elements. And the gas, because it says oxygen in here. All oxygen is very close. And it's going to react, it says it's reactive. And it's going to form solid aluminum oxide. Okay, so aluminum oxide, let's look at my periodic table. +1 + 2 + 3. Aluminum 3 plus. And oxide, we're now -3, -2, oxygen right there. First crossing, AL2, 3, very good. And from the description, it says it is a cool. But again, I'm not done. That's not descriptive enough because it's missing the Dalton, missing the ratios. Okay, so I see I have 2 aluminum here. And okay, I see I have 2 oxygens for 3, so I'm going to try to get 6 on both sides. I'll find out I have 3. I'll find out 2 and then more aluminum. Aluminum metal reacts with oxygen in the air.
Yeah.
The door's open if you want to put your computers up.
Thank you. So the mass of the penny, just the absolute penny, was 2.43 grams, and that's pretty standard for all pennies to be around that mass. And then, so the mass afterwards, so the mass of the copper, so this is after the reaction happened, ends up being 0.09 grams. Okay? Now this is just the mass of the copper. So this is copper plus zinc, right? We basically remove the zinc. So the reaction that happened here is going to be zinc plus hydrochloric acid. And let's see if we can predict those products. What type of reaction does it look like? Well, it should be a single replacement reaction, right? You have a single atom here. It's going to replace the hydrogen, okay? So, because zinc is more reactive than hydrogen. And so, what happens is the zinc is going to end up with being zinc chloride. Now, it's not ZnCl2. Zn is a plus 2 charge. So Cl is a minus 1 charge. That means that you need ZnCl2. Okay? Just like that. And we end up with hydrogen gas. Okay? And now remember, hydrogen never sits by itself. It always has a pair along with it, so that's why it's always H2 gas. Okay? So a couple of things should jump out at you right away. Before we put state symbols, we have 2 chlorines and 2 hydrogens on the left side, and so we need 2 chlorines and 2 hydrogens on the left side. I'm sorry. 2 chlorines and 2 hydrogens on the right side, we need 2 chlorines and 2 hydrogens on the left side. There. In other words, balance your equation. So, you put those state symbols there. You should understand that this one is a solid. This one is aqueous. Now that zinc chloride we're not able to see because that was dissolved in solution, so that was aqueous, and you should have seen this as a gas. Okay? So here it is written in up here without the state symbols, and we'll go ahead and see if we can put in some values right here. So we understood that the mass of the penny at the beginning was 2.43 grams. And we know that at the end was 0.09 grams. So this was the zinc, and this is the copper. And this is just the copper, so the mass of the zinc, right, should be 2.34 grams. Okay? So that's saying that this guy right here is 2.34 grams. So we're going to fill in the rest of these right here. What is the mass of that HCl? Now, well, we'll have to use some stoichiometry to figure that out. This is the whole point of stoichiometry. So, we'll take 2.34 grams of zinc, and we're going to have to change grams of zinc into moles of zinc and then change moles of zinc into moles of HCl, and change moles of HCl into grams of HCl, right? We're allowed to do that. That's a little 4-step process here. So we're going to do grams of zinc into moles of zinc, because grams aren't useful. And so G stands for go to the periodic table. We get 65.4 grams of zinc in 1 mole. And then we'll change, do a mole ratio of moles to zinc to moles of HCl. Okay? Now, this comes from the coefficients in the equation. Moles over moles doesn't come from the periodic table, it comes from the coefficients. So the coefficient of zinc, right here, is 1, right? And the coefficient of HCl is 2. So this is a 2, and this is a 1. Hopefully you were able to see that. That's where you find that. So you're going to multiply that 2. And then we're going to change moles of HCl into grams of HCl. So G stands for go to the periodic table. You find the molar mass for hydrogen and add it to chlorine, and you get 36.5. All right. Now once that's done, you should get 2.61 grams of HCl. Okay, very nice. 2.61 grams of HCl, that seems to make sense. Okay? Hey, look, so we needed 2.34 grams, we needed 2.61 grams to neutralize that. All right? So that means that according to our law of conservation of mass, right, this should total around 5 grams. I'm just doing the math in my head, right? So use that to check your answers. And so go ahead and do part B on your own. Part B is to essentially do the same thing, except change grams of zinc into grams of zinc chloride, right? This guy. I want to find this mass. And then do the same thing, change grams of zinc all the way into grams of hydrogen gas. Go ahead and try those on your own. That's what I'll be reviewing on your paper. Question number 4 asks you to calculate the number of zinc atoms that reacted. Hey guys, you should know this one. Remember, you were going to have to start with the grams of zinc. You're going to have to change grams of zinc into moles of zinc. And then you're going to have to change moles of zinc into atoms. Atoms of zinc. Okay? How many atoms are in a mole? Remember Avogadro's number, 6.02 times 10 to the 23rd. Okay. All right. Now this next to last, or question number 5. Calculate the percent of zinc by mass in the post-1982 penny. So this one's really easy, guys. It gives a lot of students trouble. Percent zinc by mass. Okay? So what you're going to have to do is you're going to have to do part over a whole. Remember, that's what percent is always. Percent is always part over whole. So the part is going to be your zinc, right? Your grams of zinc divided by the grams of your penny. Well, what are the grams of zinc? What are the grams of your penny? Okay? Don't forget to multiply by 100. Simple enough. Percent of copper, I bet you can figure that out. Again, do part over whole. You're going to have to, except now you're going to do grams of copper divided by grams of your penny. Okay? Hopefully you can see that. It is on the board. All right. Now, the last of it, the last little questions you'll have to answer on your own. The questions and conclusions, those last 5. Now, those are, I discussed some of them at the beginning of the video, so if you need some help on that, make sure you refer back to that. Try to listen to everything that I said, and we should be able to do that. All right, have a great day.